Hey everyone. In this lesson we're going to be talking about the sky, well the night sky really, but most of the time this thing up here is blocking all the good stuff during the day. So we're going to really quickly go through some of the basics of things in the sky that you might see, patterns that you might be able to notice if you pay attention, and then we'll get into some more details focused mostly on the moon. Now, the first thing I'm going to sort of touch on is this line right here. Now, this line is essentially the path that the sun traces every day. But what you might not notice is that not only does the sun follow that path, the moon follows a very similar path, as do all the planets. All right, so the sun follows this one big line across the sky, and that line shifts position on a day-to-day basis based on, the tilt of the Earth and all of that stuff. So this line moves around quite a bit over the course of a year. Not so much when you're closer to the equator, but farther from the equator, it can make a bigger difference. Now, so the moon and all of the planets follow this line. This line is called the ecliptic. And basically, if you were to look at the solar system from outside, you'd see that all of the planets are in, their orbits are in the same orientation. They're not all twisted and turned relative to one another. So I'll explain what that means in a sec. But basically, if you look up in the sky, there'll be a very specific band in the sky in which you might see planets. Now, you could see other stuff. You could see stars there. You could see, meteorites streaking into the atmosphere there. You could see all of those kinds of things. Or you could see meteors. Hopefully not asteroids. But yeah, so you could see a whole bunch of stuff in that space, but especially the planets. So if you're looking for the planets, basically figure out what path the sun takes in the sky, and then just look at that same spot in the sky at night. Now, there is something to be careful of. Let's think about this. If it's the middle of the night, what are the chances that you look up and all the way up really high in the sky, you see Venus? And you might think, well, Venus is a planet, so why not? The thing is, Venus is closer to the sun than the Earth is. So Venus should never be on the opposite side of the sky relative to the Earth. Let me show you what I mean. I'm going to get rid of this ground that we have here. So, first things first, that line, that ecliptic, basically what it means, the reason we have it is because if you have the sun here, you've got, let's say, Mercury's orbit right there, and we've got Mercury, and then Venus's orbit. If I try to draw them, the way I'm drawing them, they're sort of kind of 3D isn't really giving the whole picture. So a better way to draw it, this would be the way that you would normally see them drawn, that you see these rings that they don't quite overlap each other, but they almost overlap each other. That's just so that you don't get confused. If you look at all the orbits as flat as you can in the solar system, you've got the sun in the middle, and then Mercury's orbit it's a little bit tilted, but it's not that far off from center, or from being kind of flat. Venus's is pretty much flat. Earth's is pretty much flat right on top of this. Mars is pretty much flat on top of this, and those orbits just get bigger and bigger. Basically, you have Jupiter orbits along this, goes behind the sun, comes out the other side, and then continues its orbit on this. Mercury gets a little bit off, that it comes in front, stops, goes behind, and then comes back and retraces its steps. But basically, all the planets, to us, look like they're just sort of moving back and forth, especially Venus and Mercury. The other planets, they do move around a lot more in the sky, but they're all kind of along the same line. So if we looked out towards the outer planets, you would see, you're standing here on Earth looking up into the sky. So if you've got the sky here, Saturn's orbit just kind of goes like that across the sky. It's going to make a big circle around the sun. Even farther past it, you've got the orbit of Uranus, and you've got Neptune, and you've got Mars, and you've got Jupiter, and they're all orbiting in the same region because the orbits are all kind of in the same line with each other. So it would be like if you had a record player, if you know what a record player is, basically if you have a record player, the grooves in the record player, that's a horrible circle, the grooves in the record player are similar to the orbits of the planets in that they're all in the same plane. There's no thickness to them, as in if you looked at the solar system from above, you would see the orbits like this, but if you looked at the solar system like this, the whole thing would appear almost flat. Alright, so that's how our solar system works. If you're on Earth over here, and your orbit takes you around the sun somewhere over there, and Venus is right here in front of you, sure, when you look from above, you can see the clear difference between the two. But if you were entering the solar system flat and looking at it like this, you don't see Venus's orbit go left or go, up and down and away from you. You only see it veer in one direction and veer in the other direction, and that's it. You don't have any perception of depth, really. It might get a little bit dimmer, but that's it. Similarly, for the outer planets, if Venus looks out at Earth, it can see Earth go left and right and maybe all the way around, but it can't see Earth go significantly up or down. The whole solar system is very, very flat. All right. The other thing is constellations in the sky. A lot of astronomers use constellations kind of as landmarks. It was a thing sort of done by the ancients to landmark things in the sky. Stars, planets, time of the year, all of those things were landmarked in the sky. But it's not of the utmost importance, so I'm not going to focus on it too much right now. What I really wanted to focus on was that bit with the ecliptic. Alright, so that ecliptic is basically if you took the sun, you have the sun in the middle, you've got Mercury's orbit like this around it, and then you've got Venus's orbit like this around it, Earth's, Mars, Jupiter's, Saturn's, and so on. You go all the way out to the last planet. You can see that most of these orbits, just aside from my poor drawing on that side, they just sort of cross over each other, and that's why if you were on Uranus looking into this section of the sky, you're not going to see any planets up here. You're not going to see any planets down here. You're only going to see them in this section in the middle because that's where all their orbits go. Alright, so hopefully that makes sense. You don't have to worry about writing or drawing that in any sort of detail. It's just something you should kind of know. So I understand it's hard to get a picture of that. But you should know that that's why. So the ecliptic, we have the ecliptic because the rest of the solar system is remarkably flat. Alright, now with that flatness, that means if I have the sun over here, oops, I hit the table while I was drawing that. If I've got the sun over here and Earth over here, if the solar system is really that flat, it should be possible for Venus to be orbiting around the sun and then just come sit right in between the sun and the Earth. Right? Now, this does happen, and it's called a transit. When a planet does this, it's called a transit. Now, this situation where you've got the sun, Venus, and Earth all in a neat little line, from Earth, it looks like you've got this giant sun, and then you see this tiny dot come up in front of the sun, and that's basically the shadow of Venus. And if you track it over an extended period, you'll see that dot actually travel across the surface of the sun, and it's really just Venus progressing through its orbit. Now there is a special case with these objects lining up, and that is in the case of an eclipse. So, there are two types of eclipses. So the first type of eclipse is a lunar eclipse, all right? So the first one is a lunar eclipse, and this occurs when the Earth comes between the sun and the moon. And basically what happens here is the Earth casts its shadow on the moon. So instead of seeing the moon brightly illuminated, it's all in Earth's shadow. And what you get is you don't actually get a black kind of color to the moon, you get more of a red color to the moon. And the reason for that has to do with the fact that the sun emits all different colors of light. We perceive it as white light, but in it are reds and yellows and blues and greens and violets and all of the good colors out there. So we've got the whole rainbow out there. If there was no sun, everything would be black. We perceive it all as white, but it is broken up into these different colors. So you'd think if the Earth is blocking out the sun, then the moon should look black. But the thing is, some of those light rays, they're coming from the sun, and they just skim the Earth on their way to the moon. They pass through the Earth's atmosphere, so they don't get absorbed by the Earth, but they pass through Earth's atmosphere. And the thing is, if you look at the sky on Earth, the sky on Earth is, unless you live in a very strange place, the sky on the Earth is blue. Now, if the sun emits all different colors, it emits red, orange, yellow, green, blue, indigo, and violet when it starts, then let's say it gets to Earth, and out of these 7 colors, let's say violet gets absorbed by the Earth's atmosphere, or will not necessarily absorbed, scattered by the Earth's atmosphere. It doesn't get to pass through undisturbed. Indigo gets scattered by the atmosphere. Blue gets scattered by the atmosphere, and let's say some green gets scattered by the atmosphere. All the remaining light that's going through is red, orange, or yellow. And so when it hits the moon, the moon can only reflect the light that's coming to it. And the light that's coming to it is all this orangey-ish, reddish kind of color. And that's why when you look at the moon during a lunar eclipse, it doesn't look black or dark gray, it looks red or orange. There was a lunar eclipse a few months ago. I don't know if any of you were up at night to see that one. It was quite orange that night. So this is the first type of eclipse. This is a lunar eclipse when the moon is completely shadowed by the Earth. So the Earth comes in between the sun and the moon. Now the second type of eclipse is perhaps more exciting for us Earthlings. This one is called a solar eclipse. And this occurs when the moon passes in between the Earth and the sun. And so basically, the reason this works the way it does is the moon is about 400 times smaller than the sun, but it's also about 400 times closer to the Earth than the sun is. So when you look up at the sky, the moon and the sun look the same size, because the moon is a lot smaller, but it's also a lot closer, so it looks bigger. And the two look very, very similar in size. Now, of course, for a very specific region on the Earth, you'll have the entire sun blotted out by the moon. And so that's kind of this region. I don't know if I can draw this particularly well, but I'm going to try. So basically you've got, I haven't drawn this very well, but basically you've got these rays from the sun. I've drawn this awfully. Let me move the moon closer to the Earth. There, it's a bit more realistic now, perhaps. So you've got the moon blocking out light from the sun in this space in the middle here, and then you've got these light rays from over here that also get blocked out by the moon. So all of this whole space behind the moon is completely devoid of light from the sun. You've got the upper extreme boundary of the sun over here, and the lower extreme boundary of the sun over here. There's no light coming from down here. There's no light coming from up there. So all this light is coming towards the Earth, and the moon is completely blocking out the light in just this little section right here. All right, so if I zoom in on that, well, I'll zoom in on that in a sec. But basically, you can also have a section where the sunlight is not completely blocked, but it's partially blocked by the moon. And that's in this section right here. All right, so I'm going to zoom in on that in just a sec. So basically what you get is you've got the Earth here, and you've got the moon over here, and you've got these rays from the sun that are getting blocked out just right here in this little tiny space. It's not going to be a very wide space. This is called the Umbra. So this whole space right here is the Umbra. Now you'll also have light rays from the sun that come here, and they sort of get a little bit blocked out by the moon, but not all of the rays get blocked out by the moon. Some of them do. And then the same thing up here, some rays get blocked. I've drawn this too steeply. Some rays get blocked by the moon, and that's in this whole space right here and right here, that some of the light gets blocked, but not all of the light. And those two regions, right here and right here, these are called the penumbra. And so they basically, you've got on the surface of the Earth, you'll have a really dark patch, that's where the Umbra is, and then you'll have this not as dark patch, which is created by the penumbra of the moon. So basically, if you're anywhere here inside this region, you'll see a total solar eclipse. But if you're somewhere out here, you'll see a partial solar eclipse. So a total solar eclipse is when you've got the sun, and then the moon looks the exact same size, and it comes right over top and covers the sun. Not for very long, but it moves kind of over the sun and then comes out the other side. A partial solar eclipse, they still look the same size, but the moon just misses the sun, at least, a little bit. You've got the moon sort of down here, and it's moving, let's say, directly to the left. It's never going to completely cover that white sun in the back, right? So it gets partially covered, but not completely covered. So this is how the two different types of eclipses work. In the next video, we're going to talk about different places in the sky where you could see planets based on their orbits. All right, so we're going to talk about planets and how they move through the solar system in the next lesson, and then that'll sort of continue on into the moon, more on the moon. Okay, so we'll stop there for now, and we'll pick up in the next video.